So this question says, a person standing on the edge of a cliff throws one ball straight up and another ball straight down at the same initial speed. Neglecting air resistance, the ball that hits the ground below the cliff with the greater speed is the one initially thrown up, down, or the same speed when they hit. So this is a kind of a weird question, but it says that we have two conditions. We have a case where we throw an initial velocity up and a case where we throw initial velocity down. And we're going to look and see if they start at the same position, which one hits with V final larger or smaller. So you could put in all the values you want. You can use the equations V equals V naught. You can use the V is equal to V naught plus AT, and X equals X naught plus V naught T plus 1/2 AT squared, setting a coordinate to be in the upward direction, and this is going to be a final position of 0. We can go through this and solve this in this way, solving out to figure out what is the final velocity of both of these two, given these conditions. And what you'll actually find out is they hit at the same speed. Not a logical answer. Most people do not get this by guessing. There's a second way to think about it. It's actually kind of a nice, concise way of thinking of it. And we're going to look at this one here. So this object is going to go up, and then it's going to come back down. When it crosses this point coming back down, it's going to have some initial velocity, or some velocity 1. Not the initial velocity, but its velocity at some point later. But it's at the same position that it goes at. So what I can do is I can solve this equation first of going up and coming down. And if the velocity goes up and comes down and it takes a full time to go through this cycle, I'm going to solve that my final velocity in the downward direction, actually I'm not going to solve this. It can be reasoned out that the velocity that this guy goes is exactly opposite of its initial velocity, or the speeds that they cross. The speed this ball returns going in the downward direction is going the same speed as when it was released. So really, this going up, when it crosses this line, it's the same as going down, which is exactly the same as that case over there. So it's a pretty classic problem to solve to figure out what is its speed when it hits the ground again. Just, we start with an initial, that's the one that I really wanted to do. My initial position, I'm going to relabel this to be x equal to 0 up here. So if I start at 0, or if I end at 0, I start at 0, and I ask, what is my V naught t plus 1/2 AT squared? This is actually a minus GT squared. And I use the other equation, V is equal to V naught plus minus GT. I can solve these, and I'll find that the only condition that solves these two equations will be the case when V naught final is equal to V initial. When the velocity is the same magnitude, but in the opposite direction. Separate way to solve this. Any of these ways will work. I personally like the way of just thinking through it, and I know that a ball, when it returns to its original position, is going the same speed as when it was released, if it ends up at the same height.